All right, so we want to solve a quadratic equation by completing the square. I'm doing this particular one on my own because the method that Lumen does it slightly different, okay? So I want to go over the way I did it in class. So solving by completing the square, right? So solving a quadratic equation by completing the square. All right, there are a few things to note here. I'm shifting the camera, sorry about that. All right, so there are a few things to note here, solving by completing the square. There's a process that you go through before you even start to try to come up with any form of a factoring or seeing how your square works out. And this process is where I differ slightly from what we have online, all right, on Lumen. All right, so let's complete the square. All right, so let's look at this expression here. We want to complete the square. Let's look at this expression. So I have x squared plus 5x, all right, plus 2. X squared plus 5x plus 2, and I want to complete the square. Now, what you want to do first is you want to identify your b. Okay, so this case we have a is equal to 1. We're not working with things in which a is not 1. So a is 1 here. So therefore, what we're looking for in the end is we're going to look for something that has the form x plus b over 2 squared plus some number c, right, minus b over 2 squared, all right? So we're looking for something of that form, okay? All right, so, and of course it's kind of good to, well, I guess b over 2 is good here. But just remember, put it in parentheses because you're squaring everything. All right, so let's go back to the example that I just mentioned and see if we can apply these principles. Okay, so we have x squared plus 5x plus 2. We want to complete the square with that. Well, you need to note that b is equal to 5. So b is equal to 5, which means b over 2 is equal to 5 over 2. All right, and also now c is equal to 2. All right, so c is equal to 2. All right, so we got everything we need now. So we're going to apply this. What we're trying to get is something of the form x, trying to get something of the form x plus b over 2 squared plus c minus b over 2 squared, all right? Okay, so that's what we're trying to get. All right, so now we have everything that we need because if you notice here, we have our b, which is b over 2, which is 5 over 2. So we have here is x plus 5 over 2 squared plus, we know what c is, 2 minus 5 over 2 squared. And we just completed the square. Of course, you can write it in a simpler way, but we just completed the square because here we have something that is squared. That's it. And of course, we have that with other things added, which we can simplify, all right? So we just completed the square. All right, so now what I'm going to do now is I'm going to solve a problem using this, what we just did a while ago. So let's suppose you are asked to solve the quadratic equation. After having completed the square, you are asked to solve x squared plus 5x plus 2 equals 0. In fact, it could be any number. I'm just using 0 here. I could put any number at the right. So what's going to happen, as we saw a while ago, when we completed the square, we got x plus 5 over 2 squared plus 2 minus 5 over 2 squared is equal to 0. So what I'm doing here is I'm going back to what we just had. This thing right here that I'm highlighting in the yellow turns out to be all of this. That's what that turns out to be. All right? So as we saw in class, that's what this turns out to be. And so now, all I need to do now is I need to simplify this thing, right? So what I have, again, I'm going to keep the square part until the end. So I have x plus 5 over 2 squared. That quantity is squared. Plus 2 is just the same as 8 over 4. Just notice that 2 is 8 over 4. When I square this, 5 over 2, I'm going to get 25 over 4. And that's equal to 0. All right? So that's equal to 0. So what I'm going to do now is I'm going to solve that. Solution is now pretty much easier than, that's easier to solve than, it's clearer what's going on here than just looking at that. All right? You can't just say x equals something from here, but here you can almost say that. All right. So what I have now, again, I have, rewrite what I have. Right, I have on the board here is x plus 5 over 2 squared plus 8 over 4 minus 25 over 4 is equal to 0. So I have here, right? And so now I can simplify. So I'm going to simplify this. We know about fractions. Right, so simplify that, and I'm going to get x plus 5 over 2 squared plus, or you can say minus if you want. Let's just say minus. Let's take that out. This is not a multiplication. This is just, I don't have an eraser for this. So that's gone. So I'm subtracting whatever this is. I know it's a subtraction because it's going to be negative. 8 minus 25 is going to be negative 17. So I have negative 17 over 4. All right. Which now I want to solve this. So what I want to do is I just want to add 17 over 4 to both sides. All right. And so I'm going to write this. This is going to cancel out. I need to use a pen because I need to be able to hold this in the page. So that cancels out. And what I have left on the left is x plus 5 over 2 squared. 17, negative 17 over 4 plus 17 over 4 cancels out to 0. And now what I have on the right is still 17 over 4. All right. Okay, so now I'm just going to simplify that. Simplify that. And so what I have now is I have on the left, I have x plus 5 over 2 squared. And on the right, I have 17 over 4. And so now what I do is I want to take the kind of square root of both sides, right? The square root of a number should give me the absolute value, right? But I'm doing something kind of illegal here. All right. All right, so I'm kind of doing that. But just don't forget, when you take the square root of something, what you have is like an absolute value. So while you are trying to think about the cancellation going on, you have to think that you're working with something that's absolute value. All right? So what does that mean? If you're working with something with absolute value, that means you have to take a plus or a minus. All right? So again, you're working with something that's absolute value. Why am I keep on saying absolute value? Because when you take the square root of something that's squared, you're basically dealing with absolute value. All right? And so that's going to give you two possible solutions unless your solution is zero. I mean, unless your absolute value works out to be zero on the right. Anyway, so what happens here is now I'm set to go. So now I'm going to subtract 5 over 2 from both sides. All right, and so what I have, this cancels out, and what I have now as my solution is I have my x here, and I have minus 5 over 2 from this. I'm combining, adding, and now I have plus or minus. Square root of 17 is still irrational, so I leave that. It's nothing I can do. And then the square root of 4 is 2. And so that's going to be my solution, all right? X is equal to minus 5 over 2 plus or minus 17, or square root of 17 over 2. So that gives me basically two solutions. This added to root 17 divided over 2 is one solution. And the other solution, of course, is this same thing, subtract root 17 over 2. So those are my solutions, all right? So this is basically how you do difference of squares. I mean difference of squares. This is how you do completing the square. Sorry. All right. So that's how my method is different from the method on Lumen Ohm. Okay. Let me do one more. Okay, just do one more. All right. All right, so let's suppose I have, this time I have x squared plus 6x, make the computation a little easier this time, minus 5 is equal to 2. Let me just say that's equal to 2. All right. So now what's going to happen, some people basically do a whole process where they're adding b over 2 squared to both sides, but I think that's actually unnecessary. I personally think it's unnecessary. What I do is I try to complete the square by remembering that I'm looking for something in which I have x plus b over 2 squared and plus c minus b over 2 squared. And the reason why I'm doing that, and that's going to be equal to some number, right? Equal to some number over here. And the reason why I'm doing that is because I just want to maintain what we have been doing with completing the square. So this is my b. 6 is b. And my c is negative 5. Right, so I have everything I need. So what I do now is I basically substitute. So if obviously if b is equal to 6, then that means that b over 2 has to be equal to 3, right? If b is 6, b over 2 has to be equal to 3. And so what I have now is basically I just go straight. B over 2 is going to be 3. I know c is there from negative 5. And I'm adding back to this, right? I'm adding back to this. Not adding back, rather. I'm subtracting. I'm subtracting from that. 3 squared, because that's what b over 2 is. And that's equal to my number here, which is 2, all right? Okay? So again, this is a subtraction. Sorry about that. Let me see that. Okay, cool. All right, so now what I have now is I have to find out what this is, which is not too bad. It's just going to be x plus 3 here squared. X plus 3 squared. And now 3 squared is going to be 9. So remember, I'm subtracting 3 squared, so I should put this here. So I'm not squaring negative 3, I'm just squaring the 3. So what I have here is negative 5 minus 9 is equal to 2. All right, negative 5 minus 9 is equal to 2. X plus 3 squared minus 5 minus 9 equals 2. That's what I should say. And so I want to simplify that. So in essence, what I have is x plus 3 squared minus 14 is equal to 2. And so now what I can do, I love the way this problem is going to work out. It's not too bad. So I'm going to be adding 14 to both sides. Add 14 to both sides. It cancels out. I'm going to have x plus 3 squared is equal to 16. Nice. And so now going through the square root process. Just remember, when you're doing the square root process, you need to have in the end a plus or minus. So this process here needs to have a plus or minus on the right. When you take the square root, you have to think about plus or minus. So what I have here is the square root undoes what it's supposed to undo, and I have x plus 3 left. X plus 3 is plus or minus square root of 16. So that means x plus 3 is equal to plus or minus 4. All right, so this one is going to work out nice. Oh, good. All right, so I'm going to be subtracting from both sides 3. So I subtract 3 from both sides. All right, and what's going to happen is I'm going to get x is going to be equal to two things. It's going to be negative 3 plus or minus 4. All right, so x is going to be equal to negative 3 plus or minus 4. What does that mean? What does that mean? So let's just do this for a minute. What does that mean? So we had x is equal to minus 3 plus or minus 4. Well, that means two things. That means on the one hand, x is going to be, to the first part, x is going to be equal to minus 3 plus 4. So that's one option. So that means that my two options are going to be x equal, on the one hand, minus 3 plus 4, which is equal to 1. On the other hand, x is going to be negative 3. Second option here is going to be negative 3. Same thing here, this time minus 4. So x is going to be negative 3 minus 4, which is going to be negative 7. So my answers are x equal 1 and negative 7. Okay. So those are my answers, all right? X equals 1 and negative 7. And that's it. That's basically how you complete the square. I did something in class where a is not equal to 1, but I think if we have a case where a is not equal to 1, I can almost see us having you be able to divide that out to have a come back to 1. So this is enough.